Today we are going to learn about the hash table. So last time we already learned about the map. So if you review a little bit about the map, it contains of the key and value. And we also learn about the priority queue. We also have the key and value. Okay? And the concept of hash table is also similar with the map, but we need to understand how the hash table works. And we are going to learn about the hash tables, and then we are going to learn about hash functions and what is the detail of the hash tables. And then there will be a concept about collision handling. So what is collision? So let's check. So the hash tables, what is hash table? So in the idea of hash tables, we can see something about array, or maybe we can say about map. Okay. So let's recall the notion of map. Okay. You still remember map? In Python, we have dictionary to represent the map. Okay. But I think I will just use map for the general notion, because if you use the dictionary, maybe it is only for the Python, because Python provides the embedded dictionary. But in other programming language, for example, if you use the Java or C, they don't have the dictionary. So you need to understand about map. In the map, it supports the abstraction of using keys as index. So if you still remember, we use the MK. So K is the key, and then we want to access the value. So for example, I want to know what is the value of the student ID. So I want to know what is the name of one student ID. Then you can just have M, it is a map, and then put the key inside of the square bracket. And if you are using a map with the n items, if we know the key, if we know the key, let's say the key, you just use the general key like the index in array. For example, I use the key with integers from 0 until n-1. So this is similar with the array, but we still use the concept of map, because the key is a little bit different with the array. In array, you need to have the sequence, but in the map, you can have no sequence. So let's assume that we have the 0, 1, 2, 3 until 10. So this is the key. Okay, so it is the key in the map. And then we have the big N. Big N is to represent the number of items. Now, if we want to make it more general, so let's suppose I have 10 keys. So this is, we want to say that we have limited number of key. We have limited number of place. So what should we do if our key are not integers in the range of 0 until n-1? So let's say I have a place like 100 place, but if I want to explain the key is an integer, that will be easy, because I just put the key is 0, then it is like index 0. If it is 5, then it is index 5, similar like that one. But if the key is not integer, if the key is not integer, so it can be anything, it can be text or it can be character, yeah, then we need to use hash function. So what is hash function? It is a function to map the general keys to corresponding index in the table. So it means like this one. I have, this is the social security number. For example, this is the same with what I can say, the ID card. Okay. So it's the same with the ID card, and there is number. Okay, maybe this is a number with 10 digits. Okay, and then I want to put this number into a hash table or into a map. But how can I put this one into the map? So there is one way. We can find the 4-digit, the last 4-digit. Okay. The last 4-digit means 0001. The last 4-digit is 00002. The last 4-digit is 0004. Then I can just assume that if the last digit is 1, I put it into the key equals to 1. If the last digit is 0002, then I put the last, I put in the index or in the key equals to 2. If it is 4, then I put in the key equals to 4. So this is the simple hash function. So I don't need to generate any key, but I generate the key from the value. So the hash function and hash table, okay, the hash function, it's will map the keys of a given type to integers. So a given type, okay, a given type is anything. It can be string, it can be long numbers, okay, or it can be a character, and we want to convert it into integers, and we want to convert with a fixed interval. Let's assume here we have 0 until n minus 1. So let's say, yeah, I put this figure. If you have a bookshelf, okay? So we have a bookshelf, and then you will have like limitation of the space. So here, like we have 1, 2, 3, 4 columns, and we have 1, 2, 3, 4, 5. So we have 5 rows. Okay, so we have limited numbers of space, and we want to map for every given type, a given type, into integer. So I want to place, for example, this paper. I want to place it into one slot. I want to place another paper into the other slot. Okay. So this kind of thing, yeah, we can just imagine in the real world application is like we want to put anything into this bookshelf. So there's one function. Okay. So this is one example. We can use the x mod n. Means every number or every item, it will be calculated with modulus divided with the n. N is the number of keys that you can have. So it is a hash function for integer keys. The integer its x is called the hash value of key x. So when we have this value, okay, so we have the hx, it is the hash value. Hash table for a given key consists of hash function and array. So we use the concept again, array, because if we have kind of slot, okay, we have this slot. Oh, so this slot. Oh, sorry. So this slot, yeah, is the same with array, but where how we put the value into this slot, we need to use hash function. So the example here, we use the x mod n. So there will be another way for this hash function. When implementing a map with a hash table, the goal is to store k comma o. So k is the key. Okay. So k is key, and o is the object or the value. Okay. And then the object or the value will be pasted into the index I, and the hk is the function. So let's say that the function is using the mod. So for example, okay, so for example here, we want to use the social security number, and we have the 9-digit positive integer. Okay. So this is not 9, right? Should be 10. Okay. So 9 is the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. If we calculate the number of digits, we have 10 digits, but the space we will have like 9. And I just want to use the 4 last digit. So in our hash table, we can use array of size n until 10,000. So for example, yeah, because I want to use only the last 4 digits, so it means the array will be from index 0 until 9999. Okay. Can you understand? Because we have 10,000 items, okay, we have 10,000 place in an array, so the index will be from 0 until 9999. So this is like we have 4 last digits. So if it is 1, then we place into the key 1. If the last digit is 2, we put into the key equals to 2. If we have the key, the last digit is 9998, we put into the key 9998. Okay. So how we can make the hash function? So in this case, the hash function is not that difficult. So we just have the x equals to the last 4 digit of x. So we call this is the hash function. So the hash function can be anything. You can design by yourself, but for this one, maybe the hash function is the last 4 digit. So there's another example like this one. Maybe this one is another hash function with not with a function with the mode. Okay, I will explain this one with a later example. So what is hash function actually? So hash function, there are 2 specific way for the hash function. The first thing, yeah, a hash function is usually specified as the composition of 2 functions. The first, we call it hash code. Okay. What is hash code? We have the key, and we want to convert, or we want to transform into integer. For example, I have the value before. The social security number is 202.159.0001. So we have this value, or we have this key, and then I want to convert it into a kind of integer. What is this integer? Of course, I know that I'm going to change this one into last 4 digits, so 0001. After I get this integer, or the integer can be, say, is 1, okay, then I would like to compress. What is the meaning by compress? Compress means if there are more than one value in between 0 until n minus 1, then we need to compress. So the hash code is applied first, and the comprehension function is applied next on the result. This one, the hash code is applied first, and then the comprehension function is applied next on the result. So we have hx equals to h2. H2 means we want to convert the integers into the size of the map, and then h1x is the hash code. So sometimes the keys is not number. For example, if the key is a name, for example, Bernardo, how can we convert into integer? Okay, so there will be a way. For example, you want to get the first character B. Okay, so the first character B, let's suppose I assume that the character B is, I forgot the ASCII code. So if you learn about the computer programming, you will learn about the ASCII. It is the American Standard Code index. So whatever you have the character, there will be a number. So the ASCII code for the A, small a equals to 97. Okay. So maybe the big A is plus 26, 124. I'm not sure. I forgot what this one. But let's say if I want to just use, okay, not use the A. For example, I want to use apple. So apple is the first fruit. So I want to put this one as the key. And I know that A is the first letter or the first character, and I want to change into integer, 97. Okay. And then let's suppose I have the size n is only 20, for example. Okay, then I need to fit this 97 into the map size, which is 20. Then we have the integer value. We need to fit it into the number of the map. So that's the meaning by the hash code. So this is the hash code. We need to convert from the key, which is apple, into integer. And after we get the integer, we will compress into the size of the map. For example, we have 20, then we will fit it. So we can use the mode function. For example, 97 mode 20. Then it will be placed into the place 17. So the goal of the hash function is to disperse the keys in an apparently random way. So this is very important, especially if you want to apply something like placing a password, okay, or placing a new customer in your online store. Okay. So the hash function will be helpful to put the user in the random value. So the hash code, what does it mean by the hash code? The hash code itself, it is a kind of memory address. So we can reinterpret the memory address of the key object as an integer. We can reinterpret the memory address of the key object as an integer, good in general, but except for numeric and string keys. Okay. So in the memory address in the computer, usually we have the hash function, and usually we have the hexadecimal. Okay. We have the hexadecimal for the memory address, but we can represent with the numeric with strings. Okay. We do not want to use that kind of numeric and string, okay, but we want to cast into integer. So if we have the memory address, usually the memory address is something like, if I can say 0x to 5ff, for example, like this one. This is one of the example in the hexadecimal in the memory address. I do not want to use this key because it is a little bit complex. So how can I interpret this one into integer? So we want to cast into integer. So we can reinterpret the bits of the keys as an integer. Yeah, there is a way to convert this kind of hexadecimal to integer. So the component sum, yeah, is one of the way for this kind of memory address. We can partition the bits of the key into components of fixed length, like 16 or 32 bits, and we sum the components. Yeah, so usually we can have like 16 partition and then 0, 1, 0, 1, 0, 1, or yeah, something like bit, and then we sum. There's the hash code for this one. We say that it is suitable for numeric keys of fixed length greater than or equal to the number of bits of integer type. So if we have very long bit, yeah, so 8-bit, usually we call 8-bit if we have 1, 2, 3, 4, 5, 6, 7, 8. Okay. So the bit means the space. So if it is like 8-bit, so there are 8 space, and this is the value of 0, 1, 1, 0, 0. So this is how the computer works to understand what is the data in this computer. The longer bit, of course, it is the better because the computer can understand more information. So the 16-bit is higher than 8. So of course it is faster. 32 bits, it means they have 32 space. The current computer is 64-bit. So now, yeah, it means the computer can understand more information. So the hash code, yeah, it can be something like the memory address and cast into integer. Or there is another way for the hash code. For example, we can just apply with the polynomial accumulation. So you cannot just sum, but we can do with polynomial. Do you know what is meaning by polynomial? So the polynomial means we want to find a square. Okay, the square means let's say if we partition the bits of the key into a sequence, for example 8 or 16 or 32, so we have the sequence. What is the 8 sequence? What is 16 sequence? And then what is 32 sequence? And then we can evaluate the polynomial. So let's say that if I have a0 plus a1z, okay, so here is the sequence. So let's suppose I have 8 space. Okay, so for example, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 space. So each of this, we have a0, we have a1, and then we have a2, and so on until we have a7. Okay, and then we want to evaluate the polynomial. So the value of a0 is just a kind of constant, and then we have a1z. Okay, if we have a1z, so we put a fixed value of z and ignoring the overflow, and then we have the second, we put the z power of 2. If we have the third index, we put z power of 3. We have the element 4, then we have z power of 4, and so on. So this kind of polynomial accumulation, yeah, it is suitable if we want to use for the string. For example, if z equals to 33, then it can give at most 6 collision on a set of 50,000 English words. So for example, if we put the words in English, okay, there are many choices for Z. For example, zebra or zero. Okay, so those words can be placed into one map, and we call it 6 collisions. So there might be collisions. Later we will learn about this collision with this kind of polynomial. So the polynomial Pz can be evaluated with the On time using the Horner's rule. Okay, okay, I will skip this one because we have no much time to learn about the Horner's rule. But yeah, this is the idea of the polynomial. So the other kind of hash code, yeah, there are many hash codes, but I just explained those two about the hash codes. And after we do the hash codes, we have the compression functions. So the compression functions, so if you still remember, we have hash code. Hash code is to convert from key into integer. And then the compression function is to convert from integer into the map size or array size. So the compression function, there are several ways of the compression function. For example, we can just do the division. Division means we just divide. If we have the y mod n, so it means the number y always be in the size of n. So you know, for example, in the Q we already learned about those things. If we have the size equals to 10, okay, but now I have the value is 15, and if I want to place into the array size, then I can say like 15 mod 10, then it will be 5. So I can place the value 15. So the key now becomes 5. The key is in the index 5, and then the value is 15. So something like that. So now I need to understand where is the key. Okay, the key I'm using the mod n. Okay, so that's one way. The size n of the hash table is usually chosen to be a prime. Do you know prime? Prime number. Prime number is a number that can be divided by 1 and its own number. So 2, 3, and then 5, 7, 13, 17. Yeah, those are the prime numbers. So the compression function, if you want to apply this into a map, it is recommended that you can have the hash table with the prime number. The reason has to do with the number theory and is beyond the scope of this course. Okay, so yeah, I do not want to explain this one. Actually, there is a reason why we need to use the prime number, but yeah, I think I will not explain this one. It's just a suggestion. If you want to have the hash table, just choose the prime number. Or the other way, we can have this one, multiply, add, and divide. So we call it MAD. So this MAD is the, we have H2Y. It means we have A and B. A will be multiplied with the value of Y plus B mod n. So A and B are non-negative integer. So A mod n not equal to 0. So if A mod n not equals to 0, so for example, if we have 15 mod 5. Oh, sorry, I think it's not 5. 5 can be divided by its own number. Yeah, that's fine. So if 15 mod 5, what happened? This one equals to 0. So it is not recommended to be the A. A mod n should not be 0. So A will not be 15 in this case. Okay. So there is a rule for determining the A. Otherwise, every integer would map to the same value B. Okay. So if A mod n equals to 0, then it will be always mapped to B. Okay. So that's why we can have the multiply, add, divide in order to place the data in more random format. So this is the Python code. Okay. If you want to check the details, yeah, this is the constructor, and then this is the hash function. For this hash function, we just have a very simple mode. Okay. And then we want to know the length, we want to know the get item, we want to set the item, we want to delete the item, and we want to resize. So this is the hash map piece. There is a problem when you deal with the hash table. Maybe you know that when we have the social security number, the first number might be different, but the last 4 digits might be the same. Okay. So for example, if you have the car plate number, okay, so usually when you register your car, for example, you go to mall or you go to the parking place, you need to put only the last 4 digits, and then the last 4 digits will be recognized where is your car. And then if there is the same 4 digits of the car, then they will show multiple options. Which one is your car? According to the first 2 digits or the first 2 digits with the character. So this is the same with this social security number. In the social security number, there might be the same number of the last 4 digits, 0004, 0004, but the first 6 numbers are different. So in this case, I need to put those 2 security number into the same key. So we call it, this is collision. Collision means, what is the correct? Satu. Okay. So the collisions occur when different elements are mapped to the same cell. So in this case, it is the collision. This is another example. If suppose we have those numbers like 54, 28, 41, okay, so 54 mod 13. So let's say, okay, 54 mod 13, and then 28 mod 13, and 41 mod 13. So all of them will give you result 2. Okay, so it gives you the result 2. Then the 54 will be placed in the key 2. 28 also will be placed in the index 2, and then 41 will also be placed into the index 2. So we call this is collision because there are several values in one key. In the collision handling, there are two strategies. Okay? So we can use separate chaining. In the separate chaining, it means let each cell in the table point to a linked list of entries that map there. If you still remember linked list, so we have a list, but every of this value will be linked. Separate chaining is simple, but requires additional memory outside the table. So for example, here, if I have 25, 38, 12, and 90, and then let's suppose I have only 13 space. So I have only 13 space. And then those number 25, 38, 12, and 90, they are allocated in the index 12. Meanwhile, this is empty. This is empty. This is empty. This is empty. This is empty, 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 empty. So we need more space here. So it is not good in terms of the memory allocation. So we need to handle this one with the separate, with the other strategy. So the separate chaining is one way, but it is, it requires additional memory outside the table. So we call this is the table. Okay. So this is the table that we have, and it requires more memory outside the table. So we need to have more memory to provide this linked list. If we are doing with the separate chaining, so this is the algorithm, we can just simply delegate the operation to a list-based map at itself. So for example, we just do with the get. Okay. So get means I want to get the key k, yeah, and then what is the key k? The key k is actually based on the hash code. Okay. So I want to put the k in a position of array with the hash code. Okay. If you still remember, the h case is the hash code. Okay. And it will be the index of this array. It is about the get. What about put? If we are dealing with put, it means I want to save. Okay? Get, I want to retrieve. Put, I want to save. So if I want to save, then I would like to save the pk with a value v into the index space hk. So hk is the hash code. Okay. And then I will just say it is t. Okay. After I put into the t, I will check, is t null or not? If t is not null, it means there is already one value there. If t equals to null, then you can have n equals to n plus 1. So this is to put in one place. But if you have already an item in that key, then yeah, you will have a separate chaining. The same with the remove. Okay, if in this a remove, then you just want to get from the hash code, and then when you remove the k, you want to put into one variable t, and then you'll check if it is not null, then -1 for the n. So we have this chain hash map. This is the code in Python that has already been developed. It is based on the separate chaining. So if you take a look, this one is a class of chain hash map. We have the get item. So if the bucket is from the table J, if the bucket is known, then yeah, we have the error. But if it is not known, then it will return the bucket. Or you want to set the item, or you want to delete the item, or you want to iterate the item. Okay. The other one is about linear probing. So the strategy, the first strategy is separate chaining, and the other strategy is linear probing. Okay. The first strategy is separate chaining, and the other strategy is linear probing. So in the linear probing, the correlating item is placed in a different cell of the table. So this means that we want to make it more efficient. We do not want to make a new list. We do not to make a separate chaining, but we want to place in different cells. We call it, this is linear probing. Okay, maybe due to the time, I will stop here so you can have some time to prepare for the e-class. Okay, I will continue this material on Wednesday. So any questions?